Welcome back, guys. Last section of chapter 2. So this is actually 2.6 and 2.7 combined. So we're going to be looking at square roots and then being able to order numbers. So first things first is we're going to go over some definitions. So this should be review for you from middle school. But in case you need a refresher or you never learned it, we're going to go over these. So a square root is a number which produces a specified number when multiplied by itself. Okay, so a number which produces a specified number when multiplied by itself. So off to the side, an example for you, it would be 5 because 5 times 5 is 25. Okay, a radical is a root of a number. Okay, and the symbol looks like this. The radicand is inside of the radical. So for example, if I have the square root of 2, 2 is the radicand. Perfect square. So that's a number that is made by squaring a whole number. So some examples. It's a good idea to try to memorize these. So the first 20 perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So just to clarify how we're getting that, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. So square root of a number. So if b squared is equal to a, then b is the square root of a. So some examples, 5 squared is 25, negative 5 squared is also 25. So 5 and negative 5 are square roots of 25. So that's something important that you got to take the positive and the negative, because negative 5 times negative 5 is also positive 25. So it's 5 times 5. Okay, so all positive real numbers do have 2 square roots, as I just said, positive and a negative. The positive square root is considered the principal square root. So we're going to evaluate this expression. So this gets a little confusing. There is a negative on the outside. So let's focus on the root first. So the root of 36 is 6, because 6 times 6 is 36. It's also negative 6. So my answers are going to be negative of 6, because that's what the square root is, or negative of negative 6. So if I simplify that, that's negative 6 or 6. Square root of 16 is 4 or negative 4. 4 times 4 is 16, so it's negative 4 times negative 4. Okay, square root of 64, they want the positive and the negative. They just specify that with the plus minus, so that's 8 and negative 8. Square root of a negative number is not possible, so that's no solution. The reason is that if you multiply the same number by itself, so like 3 times 3, that's positive. Same thing with negative 3 times negative 3. So there's no way we can do negative 3 times 3, because that's not multiplying the same number by itself. Negative 3 and 3 are different. So there's no negative square roots. Awesome, moving on. So I'll let you try the next section on your own, and then you can check your answers. So you can also approximate a square root. So it says the top of a folding table is a square whose area is 945 square inches. Approximate the side length of the table top to the nearest inch. This means that S is a positive square root of 945. You can use the table to determine if 945 is a perfect square. So my first inclination would be that I know 30 times 30 is 900, so that's fairly close. So I'm going to put 30 here in the middle. I know that's 900. And then I'm going to check, what about 31? What about 32? And then what about like 29 and 28? What would those be? So using a calculator, if I do 28 times 28, that's 784. If I do 29 times 29, that's 841. If I do 31 times 31, that's 961. And 32 times 32 is 1,024. So that means that 945 falls somewhere in here between 30 and 31. So it has to be between, so it's between 900 and 961. So the greatest perfect square less than 945 is 900. The least perfect square greater than 945 is 961. So the side length has to be somewhere in between 30 and 31. It is a little bit closer to 31 since it's 945, so I'm just going to guess about 30.7. Okay, so approximating square roots. So if I look at 32, I know 36 is a perfect square, and that's 6. I know 25 is a perfect square, and that's 5. So it's a lot closer to 6, so I'm going to say like 5.8. Square root of 103, I know 10 times 10 is 100, so it's a little more than 10. So I'm going to say 10.1. 48. So 6 times 6 is 36, 7 times 7 is 49. So it's going to be closer to 49, so it's really close to 7, so I'm going to go with like 6.9, and it's negative because of this negative here. Okay, next piece. So we have to classify things as real numbers, rational, irrational, integers, or whole numbers. So as a refresher, a whole number is a counting number. An integer is a positive or negative whole number. And 0 is included in that. Okay, a rational number, I'm going to go back one, can be put in a fraction. So that's also a decimal that ends. Irrational number is a decimal that goes on forever, so it can't be put in a fraction. So examples of that would be like pi, or when you get into algebra 2, there's something called e, an exponential constant. And actually, we'll do that a little bit in algebra 1 at the very end. And then a real number is just any of those numbers. So it's all categories. Okay, so they're going to ask us to classify. So we know this is 12. So that is a whole number, which means it's considered an integer. It's rational because it could be written as a fraction, and it's real. When it would not be a real number is if you had like an imaginary number, which you won't see until algebra 2. This is -7, so that's not a whole number. You don't, when you're counting, you don't say -7. You would count 1, 2, 3, 4, 5, 6, 7. It is an integer. It is rational because it could be written as a fraction, and it is real. So next one is square root of 32. So that is not a perfect square. So if you type that into your calculator, it's going to be a decimal that goes on forever. So that means it's irrational, but it's also real. So real is included in that. It's not a whole number, not an integer, not a rational number. Okay, next up, graph the numbers on the number line using a... All right, moving along. So we're going to be graphing these numbers using approximation. So I know 4/3 is like 1 1/3. I know the negative square root of 5 is going to have to be -2 point something, since the square root of 4 is 2. It's going to be closer to 2 than 3 because the square root of 9 is 3. So I'm going to say like 2.2. Square root of 13, so that has to be in between 3 and 4, since 3 squared is 9 and 4 squared is 16. So a little bit closer to 16. So I'm going to go with like 4.6. And then the square root of 9 is 3. So let's start with 4/3. So that's going to be about here. Negative square root of 5 is going to be around here. Square root of 13 is going to be somewhere up here. Negative 2.5 is here. And then square root of 9 is on 3. So then they want you to read the numbers from left to right. So that'd be -2.5, negative root 5, 4/3, root 9, and root 13. Okay, lastly, we're going to go through the same process with the real number, rational, irrational, integer, and whole number. So remember that basically everything you're going to do in this class is going to be a real number. That's going to come up later in algebra 2 when it's not. So I'm just going to check real number for everything. Starting with negative square root of 20, so that is not a perfect square. So it's going to end up being a decimal that goes on forever. So that's irrational. -9/2, we can write that as a fraction. It is written as a fraction. And it's, let's see, anything else? It's not a whole number or an integer, because an integer would have to be a whole number. So that's it. 0 is an integer. So remember, whole numbers are counting numbers, 1, 2, 3, 4, 5, and so on. Integers are whole numbers that can be negative or positive, as well as 0. So like -2, -1, 0, 1, 2. Those are integers. And 0 is also considered a rational number because it could be written as a fraction. So it could be 0 over anything. Okay, continuing on, square root of 7. If you put that in a calculator, you get a decimal that goes on forever, so that's irrational. 4.1, that is considered rational because it's a decimal that ends. And then 5.2 with a bar, so that means that it is a repeating pattern, so that's also considered rational. Let me go back and add that over here. I forgot that. On rationals, it's a decimal that ends or a decimal that's repeating. Okay, so that is about it for the notes. I do want to do a quick summary with you. Okay, so we're just going to open this up. And I just want to do a quick summary with you on these classifications of numbers. So we've got real numbers, and that's split up into rational or irrational. So rational can be written as a fraction. It's a decimal that ends or repeats. Irrational is a decimal that goes on forever. Okay. So then within rational, we're going to have this as a big circle. There's also going to be integers and whole numbers. So I'm going to make a smaller circle. So integers are positive and negative whole numbers. So that's like -3, -2, -1, 0, 1, 2, 3. It goes on in both directions. And then whole numbers are an even smaller set of numbers. And whole numbers are just counting numbers. So how you would count. So you'd start with 1, 2, 3, 4. So a whole number is an integer and a rational number. An integer is also a rational number. So just to give you a better visual of how that chart works. So I would draw that on the back of your notes or something, or fill it in somewhere. Awesome. That's it. Great job. You are all done with chapter 2.